Oh, the rain's nearly stopped. Let's start again. Alright, so today's video, we've got a snout off a starter motor. Now, it's actually cracked nearly all the way around here, and well, yeah, that's no good. So what we're going to do is use the big F-clamp and actually clamp this in tight so it closes up the gap, and then we're going to go in with the die grinder and chew all the way out of the middle. Now, we're going to go about half the thickness of the material, maybe a little bit more, and then we're going to fill that groove in with some 40-43 filler wire. And the 40-43 is a bit softer than the 53-56 that I normally use, so it will resist cracking. Now, the die grinder, normally I use these normal bits that you get. Unfortunately, they don't really work with aluminium. They just clog up, and well, then you need to unclog them. Usually I do that by dipping them in wax, and the wax helps to free the aluminium chips out. But I've actually got myself a non-ferrous cutting bit, so it's designed for non-ferrous metals, and it's only got about 6 teeth on it that spiral all the way up, and they allow the chips to actually fly out instead of jamming in. So I'll be using that to grind it out. Then we'll TIG it up, and then once I've got it TIGged up, I'll flip it over, still clamped, grind the outside all the way through until I get to the weld metal, which will be a slightly different colour to the casting, and then I will weld the outside and, well, leave it to cool down on its own. So the longer it takes to cool down, the better it is, the less likely it is to crack again. So let's get on with it. Do some welding. Now I just let that cool for a while, and then I can flip it around and cut out the other side. Now that the inside's welded, you can see this is bubbled out slightly because of the amount of heat I put into it. Now you can still see there's a crack on the outside all the way up, so I'm going to use the die grinder, chew all that out all the way around, and then go through and weld the whole thing on the outside as well. And this is why OMG can't come in my workshop without shoes on. Every single one of these is a little spike that goes straight through your skin. These bits get the job done, but ooh, they can be nasty. As you can see, that's ground out. There's no porosity left in this side. But over here I had to go a fair way in because there was a couple of nasty holes. Like this big fella just here. But I've got that ground out as much as I dare, which is why we left so much weld on the other side. So this is ready for welding again. Now, our part's cooled down, ready to clean up. Now, it's best to use a disc that has not been used on steel. Now, if you use it on steel and then on aluminium, it'll embed particles of steel into the aluminium and they will rust. The other thing is, when sanding aluminium, it binds up with aluminium fairly easily, so a bit of candle wax will loosen up all the particles and let them fly free. So then it'll start cutting like a new sanding disc again. So all these little bubbles that weren't showing before, that were under the surface, that's something that happens a lot with cast aluminium. So it's all the impurities, I think, that just cause this issue. So what I have to do now is go along and just heat up the area until the surface tension inside the hole melts, and then it'll just pop. And then once I do that to all of them, I might have to go along with the filler and put a run of filler over the top just to get them to fill in and be a nice solid piece. Alright, so that is done. So the steps were to V out the inside, chop out as much of the crack as possible, and then fill it in. Big capping run over the top because, well, I had the space for it to stay in there. And then once the inside's V'd out and re-welded, V out the outside, weld it up, linish it back, and then go over and melt. And it's basically just running over it, melting everything, melting the whole surface, and you'll see there'll be bubbles keep popping up again and again, and you just got to keep going backwards and forwards until they stop. So it's not the prettiest part, but it should work, and is a lot cheaper than buying a new starter motor. This one is not very old at all, but it had to be modified to make it fit in the first place, so it wasn't able to be swapped under warranty. I only started the vehicle about 3 times, I think. Anyway, my friend needs his forklift back, so I'm going to let this cool and then he's coming to pick it up. And that's it for this video, and as always, customize everything, or repair what you can. Next project.